Hello everyone. My name is Smith Kumar. I am PMR Research Scholar at IIT Sandanwad. Today I am going to take the 13th lecture of the series. This is going to be extra class in which I will try to revise the entire concept which we have gone through in this whole lecture series. And apart from that, I will try to cover some problems as well on the slope stability, which may enhance your understanding on these subjects. And I am really thankful for everyone who have attended this course online, and as well as for those as well who have gone across those lectures on the YouTube. I think so. May all of you have got benefited in some way or the other. In the real sense, the series get over, but in the addition one more lecture, I will try to summarize the whole concept which we have covered during the last 12 classes. And in a meanwhile, I will also want to add some points which I always communicate with you during the each classes, like the concepts and the presentations which we discussed today will be shared with you by the NPTEL team, and the drive link is already shared with you by the NPTEL team. And apart from that, talking about some other aspects, like this lecture is also going to be recorded and will be shared with you on through YouTube link. So not to worry about that as well. Talking about the other concerns, like if at any point of time, like it only takes place during the one of the lecture in these 13 weeks. If network issue get arises and I will get disconnected, please be remain in the meeting. I will rejoin and go ahead afterward. Okay, so first of all, I will start to share my presentation and go ahead with the content. Specifically, I will try to divide the entire concept which we have discussed during last 12 classes during this session, and I think it will be very much helpful for all of you. I think so. My presentation will be visual. Okay, no problem. I think so. The presentation is visible and there is no issue of network at this point of time. So we will go ahead. And while taking the today discussion, one point I want to clarify very clearly that I will go very fastly because I want to take a revision more or less of the entire content which we have gone across during the last 12 sessions. And this is extra class, so I find that very less attendance are there, and so no problem, but I will try to add one more point for those who are watching this lecture on the YouTube. You can go across these lectures, you will find the summary concept of the entire lecture series which we have gone across, but in addition, I will prefer that you will go with those lectures as well, and apart from that, the presentation files. So that will help you in a large extent in understanding of this subject in another manner apart from what you have already learned through the original lectures. So I will try to give the some perspective, add my perspective accordingly, which help you in one way or the other. Okay, so let me start the today's discussion. Uh, it will be okay, I think so, because the time is already 3:10. So now I will start the discussions. Okay, see, we are going to study the geotechnical engineering too. In the last 12 lectures, we have gone across the several concepts of geotechnical engineering too. So we will first of all cover those concepts in a very brief, and then we will go ahead one by one. And at the end, I will also try to add on some questions specifically related to slope stability for your better understanding. So you will get the more actual concepts regarding the problem. And in the meanwhile, first of all, we will start with the shear strength, then we move to the earth pressure, then slope stability, bulkhead, everything we will try to cover in this session because this is a revision session, one extra class. So I think so it will give you a better perspective as well. Okay. So I start with the shear strength of soil because from here only we have started our class. From the first class we came to know that what is the shear strength. So shear strength is the soil. The strength of the soil is the ability of soil mass to resist the shear force. We have understood these concepts. The force which has been acting, the stresses which has been acting, that is resisted by the sum of the strength of soil, and that strength of soil is the shear strength of soil. So it is measured of the soil resistance to the deformation or failure when subjected to shear stress. Shear strength is an important property in the geotechnical engineering as it determines the stability and the load bearing capacity of the soil structure. And it is quite helpful for, it is quite needful for its understanding to find the soil structure strength for the constructing any foundation, any retaining wall or slopes. So, talking about some of the important parameters through which we find the shear strength as we have moved earlier covered the triaxial test. So there we came to know that shear strength parameter are the cohesion and angle of internal friction. The cohesion represents the shear strength of soil particle due to the intermolecular force and each more significant in the cohesive soil such as clay, while the angle of internal friction represents the resistance of soil particle to sliding and is the more relevant in the cohesionless soil such as sand. Talking about the shear strength of soil, how we can determine the shear strength of soil. So, two or three primary tests which we covered as well during our this lecture series is like the triaxial test, direct shear test, which is also known as the box shear test. So these are the, and apart from that, one vein shear test is also covered during our this lecture series in very detail. There you got the understanding about the fact that how these tests help in understanding and generate a better outcome for the geotechnical and civil engineers for before the construction of any structure. So these tests help engineers in designing the safe and stable structure by considering the shear strength properties of soil. Talking about its importance, so safety of any geotechnical structure dependent on the strength of soil, as if the soil fails, the structure found on it collapse down because we any structure which has been constructed on soil, each completely dependent on soil. If soil gets failed, so the entire structure get collapsed. I take another example. Suppose there is a seven-story building and there is a huge damage at the second story of the building. So if in any cases the second story get collapsed, the entire structure above it lead into the collapse failure. So in a similar way, the overall structure is standing on soil only. So the failure of soil led to the great disaster, it resulting in the life of loss of life as well as the economical damage. The strength of soil is therefore a of a paramount importance in geotechnical engineering. The word strength is used loosely to mean the shear strength, which is the internal frictional resistance of the soil. Because when in the first class also I have discussed about when we talk about the strength, we talk about shear strength when we're talking about soil. As you have gone through the strength of material courses, so over there you have came across the compressive strength, characteristics compressive strength. But That is not the factor with the soil. In soil, the shear strength is the most important parameter. Shear strength is required to make estimate the load bearing capacity of soil and the ability of the geotechnical structure and is analyzing the stress system characteristics of soil. So shear strength importance become very much important. Adding some points in this, the shear strength is a critical factor in geotechnical engineering as it determines the stability and the behavior of soil under different loading conditions. Understanding the shear strength is essential for designing the foundation slopes, retaining walls, and other structure. The shear strength play a crucial role in preventing the failures such as the landslides, embankment, collapses, and foundation settlement. Talking about the shear strength in granular soil, as we know, the granular soil and clay soil. So, they're talking about the strength or shear strength in granular soil. The granular soil such as sand exhibit a unique behavior under stress. In flexible boundary containers, granular soil tend to flow when it is subjected to stress, while in the rigid boundary container, volumetric deformation occur leading to the change in the shape and density of soil. Crushing, bending, and rolling mechanism can also affect the shear strength of the granular soil in a true sense. Talking about the shear strength in the cohesive soil like clay require special consideration in terms of shear strength. Compaction characteristics are crucial in achieving the desired shear strength in the cohesive soil. Decreasing permeability and preventing the consolidation settlement are the key objectives in compacting cohesive soil. Development of the shear stress and slippage is a common in cohesive soil under excessive load. Now we take a schematic diagram. Over here you can see that the two sections has been represented. One is represented as the parent body and other as a detached body. So one basic understanding need to be developed in your mind, like the soil get filled. If we take the small soil sample, the failure will be found. But if we, in a real sense, at the true structures are there, the soil section are at infinite length. So when it fails, so talking about its failure, it fails when a critical combinations of locations get formed through which the particle get detached, ultimately result in the failure. So that critical plane is the shear failure plane, and the parent body remain with the main material while the flowing body get flow on. So when the stress, applied shear stress is greater than critical shear strength of the soil, resulting in the failure at specific section. Now you can see some of the real example. Over there, the detached body and parent body is represented very cleanly. So over here, you also can see found that the soil section over there get removed from that plane, and the main sections remain stated there. So the parent body and the detached body is fall down due to the failure. There is again another cross section has been represented over there. The whole road is disconnected and the soil between them got flow down. So that is the detached body example. Now we talk about the equilibrium equation and Mohr circle. We have also came across the knowledge of the Mohr circle during our very first class. So I will carry forward those classes. So equilibrium equation are used to analyze the state of stress in soil. Equilibrium equation involve the relationship between the normal stress and the shear stress. And one more point I want to add here, the square of normal stress plus shear stress is ultimately the radius. So the equation can be represented graphically using the Mohr circle. So in the Mohr circle, the x coordinate sigma 1 and sigma 3 will be there, and the um, and generalize in the form of equilibrium equation like this. And afterward, you can see that the horizontal axis is the normal stress axis, while the vertical axis is the shear stress axis. So this type of model circle could be formed, and there are several problems also taken during the first session only. So you can go across those questions in the meanwhile. And I think so you already have gone through those conceptual points, so there will not be any problem in any one of your mind. Okay. Now, in this presentation introduces the Mohr circle as a graphical tool to use and analyze the state of stress. Mohr circle helps to determine the stress component sigma and tau are at a given plane inclined at an angle alpha. The step to solve the problem using the Mohr circle are explained along the analytical method. Okay, no problem. So I think so. Till this point, understanding is clear. Now I will move ahead. So allow me to take some water. Okay. So talking about the property of Mohr circle. So Mohr circle is a powerful tool in itself for understanding the state of stress in material, and it is applicable to the various materials including soil, rock, composites. The Mohr circle analysis is combined with the material properties such as the shear strength allow for the analysis for the real life situation in civil engineering. The sign convention which has been represented here for the Mohr circle is given over here. From this sign convention, we can plot the Mohr circle with the positive and negative sign. Talking about the simplified solution, basically ultimate our aim is to simplify the solution to solve it analytically, and the graphically is the another way to solve this problem normally in a it has been formed. So the shear failure is a common model for the failure of soil. In the simplified solution, focus is on the shear failure and the rigid body behavior. The Mohr circle is used to analyze the state of stress in soil undergoing the shear failure. The assumption is sigma x is equal to sigma 1 major principal stresses and sigma z equal to sigma 3 minor principal stresses. So this is one of the another perspective. Now, generalizing the solution, understanding the state of stress in soil in a uh, crucial geotechnical engineering. The Mohr circle provide a useful tool for analyzing the stress and failure in the soil. The simplified solution and the generalizations help in the practical application. The Mohr circle defines the state of stress acting at a given point, which is sitting on a plane along which the failure is about to take place. Talking about the more about the Mohr circle analysis, so deriving the relationship between sigma square and the tau square as a circle equation. The interpretation of the Mohr circle is representation of the state of stress in a material. There are the two stresses. One is the principal major stress, and another is the principal minor stress divided by sigma 1, sigma 3. And a major circle defines the state of stress at a point on a plane where the failure is about to occur. Application of Mohr circle in analyzing equilibrium in the various material is equally important. Now we see one picture and over there we will try to define the each and every point related to Mohr circle. So here we see that the Mohr circle have the principal minor stress, principal major stress, the zero shear plane is also represented, and the radius which has been shown for this um, will be sigma 1 sigma 1 minus sigma 3 by 2. So we have to see, we have to look into that. So over here you can see A, the radius has been represented as sigma 1 minus sigma 3 by 2, and the center position as sigma 1, sigma 3, and so much are the origin point, and the sigma 1, sigma 3, and the relation between sigma square plus tau square is a square is also implemented here. So you can see the another relation which has been relating the major and minor principal stress as sigma p1 equal to sigma x plus sigma z by 2 plus root under sigma x minus sigma z by 2 square plus tau x z square, and sigma p3 equal to sigma x plus sigma z by 2 minus root under sigma x minus sigma z by 2 square plus tau x z square. And how they are related, how they form will be shown over here. Talking about its application in civil engineering is equally important. The example of infrastructure development in the hilly terrain, cutting slopes and creating the benches of the roads and pavement. Importance of understanding the critical state of stress in such situation, and the real life case study for stabilizing slope and conducting retaining walls are the some of the applications which is served. Okay, no problem. See, now we move to the application part. So before moving to that, give me 2 minutes. So I will again come back in 2 minutes. Hello. See, we are talking about the application in civil engineering. So, what are the applications basically which can be implemented during our civil engineering works we are talking about? So, the example of the infrastructure development, specifically in the hilly terrain, cutting slopes and creating the benches of the road and the pavement. Importance of understanding the critical state of stresses in different situations, the real life case study, stabilization scope, and the construction of written. Talking about some more generalized law of stresses, like expressing the stress in terms of sigma 1 and sigma 3, and analyzing the situation where the lateral stress are more or less than the vertical stress, the passive and active states of the earth pressure. So over here, one 2 points has been mentioned. It is showing that when the sigma x is more than the sigma z, is the passive state of material, and when the sigma x is less than sigma z, will be the active state of material. And we have discussed this point in very detail when we have taken the discussion of the active and passive earth pressure after the earth pressure at rest. So there is a very good discussion has been done on this topic. So I don't think so any confusion over there. Okay. Now we will talk about the shear, some of the definition of the key terms. These all points which I am discussing, this is the revision session. So over here, the points which will be discussed it has been already been there in the presentation as well, and the content which is over here is just for the revision purpose and summarize content at I can say. So talking about shear strength, the shear strength of a soil is the maximum internal resistance to the applied shear force. Talking about the effective friction angle, so the effective friction angle is actually a measure of the shear strength of soil due to friction. When you talk about the cementation, it is a measure of the shear strength of soil from forces that cement particles apply. Talking about the cohesion, it is a measure of intermolecular forces and the apparent cohesion is the apparent shear strength at zero normal effective stress. Critical state is a stress state reached in the soil when continuous shearing occurs at the constant shear stress. 2. Normal effect stress ratio and the constant volume. Talking about the dilation, dilation is a measure of the change in the volume of soil when the soil is distorted by shear. When now we move to the Mohr Coulomb failure criteria, which we have the basic main part of the shear strength over where the effective and total stress parameter we are discussing. So now we will take some more points in detail. Where over there we will come to communicate about the different type of tests which are present there. So we will look into that. Now fine. The Mohr-Coulomb failure criteria, the functional relation between the normal and the shear stress on the failure plane can be given by the function of sigma, where S is the shear stress at failure and sigma is the normal stress on the failure plane. So S is equal to C plus sigma tan phi, where C is the cohesion and phi is the angle of internal friction. So you can see that this has also been drawn with here over there the shear strength axis and the normal pressure axis has been shown. And what is the shear strength is also dependent at a specific section. And the phi is the angle of internal friction which has been dependent over the help of this diagram. So we know that S is equal to C plus sigma dash tan phi, where sigma dash is nothing but sigma minus u, and sigma dash is the effective stress, and sigma is the total stress, and u is the pore water pressure. So the total stress minus pore water pressure is the effective stress. Talking about the definition of the shear strength. So shear strength definition we have came across at the verge of failure. So shear strength of a material disposed when subjected to shear motion, and when we go ahead, we present a mathematical definition of the weak plane. So the weak plane is that where the stress applied is more than the critical state of stress. So over here you see that the factor that influence the shearing will be the major factors will be the earthquake can lead to the relative motion between the soil layer. If fault causing one position or the ground slip down, leading to the shearing and emphasize the understanding the state of stress during the shearing is crucial for stability assessment. The other factor they could cause shearing in soil is the slope instability and different construction pieces. So we will go one by one in that. Talking about the application, because we from the starting date we have discussed that whatever we are studying, we come to question ourselves that whether it is important and what its significance, how the story of shear strength could be function. So, talking about the engineering significance of understanding the shear strength in geotechnical project, shear strength analysis help in designing the foundation retaining walls and slope. The role of the shear strength is most important in assessing the stability of the natural and man-made slope. Human activity like the construction and the expansion can alter the state of stress in soil mass, and the incremental changes in the stress can lead to the shearing, especially along the weak planes. Talking about the shear strength of soil, so the soil consists of individual particles that can slide and draw relative to one another. The shear strength of soil is equal to the maximum value of shear stress that can be mobilized within the soil mass without the failure taking place. The shear strength of soil is a function of stress applied to it as a manner in which these stresses are applied. So knowledge of the shear stress of soil is necessary to determine the bearing capacity of foundation. The lateral earth pressure exerted on the retaining wall and the stability of the slopes. So when we go ahead, we came to know that the different type of tests are there through which we can calculate the shear strength, but we primarily focus on three only, but we will go one by one with their name. So the first one is the shear box test, that is nothing but a shear test. Second one is the triaxial test, which is the most popular and also known as the uh, Brahmastra, basically, of finding the shear. So the Bayesian shear test is another factor in which the torque has been applied, and on the basis of that, we are able. The dia of Bayes is already known to us. So on the basis of that, we will find the solution for the respective problem. So the different tests which are of the shear strength are for shear strength is the shear box test, triaxial test, Bayes shear test, torque shear test, um, flat jack test, and penetration test. So the shear box test as a 2D simulation of soil condition, and it provides a plane strain or the plane stress representation of searching behavior. Okay, no problem. Now we will move to the shear box test. So shear box test is a type of test that is direct shear test, and it is a 2D test to simulate the soil condition. This test provides a plane stress representation of the shearing behavior. It is a as a limitation that it replicates the replicating a real 3D condition is not replicated by in one way or the other. So talking about the triaxial test, it is a 3D depiction of the stress on the material. It offers a better application of in situ stress condition and also help in understanding the soil behavior under the more complex loading condition. Talking about the Valencia test, the Valencia test for the soft and the sensitive soil takes place and it is applicable in the laboratory and field settings, including the offshore environment to measure the C2 shear strength in the difficult sampling situation. Talking about the another test that is a Todd shear test, it to overcome the limitation of the shear box test at the higher shearing level. Introduce the Todd surge shear are the magnitude of the strain to the sample, and it has significantly in studying the material behavior shearing levels. Talking about the flat jack test, the use of the flat jack test in the rock. um, okay, now see. Over here, the flat jack test is the one of the tests through which the shear stress could be calculated, and the penetration test is another in which the SPT is first of all found. Now, the method specifically used is the direct shear test, that is the box test and triaxial test for our analysis. Talking about the direct shear test, so this test is carried out on the soil sample confined in a metal box of the square cross section which is split horizontally at the mid height. A small clearance is maintained between the two halves of the box. Okay, no problem. See, now we are talking about the direct shear test. So the test is carried out on a small soil sample confined in a metal box of the square cross section which is split horizontally at the mid height. A small clearance is maintained between the two half of the boxes and the soil is heard along the predetermined plane by moving the top half of the box relative to the bottom half. Okay. Okay, no problem. So the soil is sheared along the predetermined plane by moving the top half of the box related to the bottom half. So the box is usually square in plan radius 60 into 60 mm, and here is a typical diagram depicting the section of the direct shear test because you can see you can find the condition which has been needed for this test, that if the soil is fully or the partially saturated, performed the metal plates and the porous stones are placed below and above the sample to allow the free drainage. If the sample is dry, solid metal plates are used. A load normal to the plane of shearing can be applied to the soil sample through lid of the box. Talking about the test on the sand and clay. So test on the sand and gravel can be performed quickly and usually performed dry as found that water does not have a significant effect on the drain distance. For clay, the rate of shearing must be chosen to prevent the excess pore water pressure building up. And talking about the procedure as a vertical load applied on the sample, the shear stress is gradually applied horizontally by causing the two half of the box to move relative to each other. A number of samples of soils are tested each other the different vertical loads and their when you shear stress at the failure each uh, plotted against the normal stress of each test. It also provides where is the no excess poor water pressure in the soil and the total effective stress is identical from the structure or failure and the failure envelope can be obtained. Some of the advantages that it offers is like it is easy to test and understand the gravels. The large samples can be tested in the larger shear boxes as a small sample can be misleading. No problem. So, talking about some more advantages, like the sample can be sheared along perpendicular to the plane when the shear strength along the features or the selected planes are needed. Talking about some of the disadvantages, the failure plane is already horizontal in a rest, and this may not be the weakest plane in the structures. Talking about the shear box apparatus cannot be given a reliable under untrained extent because it is possible to prevent the localized drainage away from the ear. Now we move to the triaxial test. So before we see the triaxial test, we have to understand this replicate the true 3D condition of the field. So the triaxial test is carried out in a cell of a cylindrical cell sample having a length of diameter ratio 2, and usually the size of the 76 into 38 into um, 3. In triaxial test, the usual size which I mean is 76 into 30 into 100 into 50. So the principal stress are applied to the soil sample out of which two are applied water pressure inside the confining cell and stress and equals, and the third particle stress is applied by loading ran through the top of the cell and is different to the other two principal of stress. The typical triaxial cell is shown over here. So before moving ahead, we will take a 5 minute break, and after that we will again come and restart our class. Hello, welcome back. So, after this small break, we will again go into very quick because we have to cover many things. We are at a very low pace up to this time. So now we will start our speed and go in a very fast and furious manner to complete our discussion for. Okay, so I'm talking about the test procedure. So the test procedure we have discussed in detail. So, but you know that how this triaxial test is performed. There is a two stage. That is the first stage is the confining stage, and the second stage is the deviated stage. Over there, first of all, we apply a stress of sigma 3 from all across using the water, and afterward we apply a deviating stress from the top, and ultimately we interrelate those terms and find sigma 1 and sigma 3 at failure, and then plot the diagram, plot the Mohr circle, and accordingly we are able to find the C and phi value. What will be C? C will be that value which make the intercept at the y-axis, and phi will be that value which make the angle with the horizontal when we plot the respective result which we have done. Okay, I am talking about the two stages. So in the first stage is that stage in which the soil sample is set in the trisal set confining pressure and is then applied. While in the second stage, the axial additional stage, that is the deviating stress, is applied, which induces the shear stress in the sample, and the axial stress is continuously increased until the sample gets filled. During the both stages, the applied stresses, the axial strain, and the pore water pressure could be measured, and depending upon the different types of test, the sum of the factor could be controlled. Talking about the different type of test which is possible during the triaxial test is the UU test, CU test, and CD test. UU test is an unconsolidated and drain test. In this test, the cell pressure is applied without allowing the drainage. Then, keeping the cell pressure constant, the deviating stress increase to the failure without the drainage. While in the consolidation and drain test, the drainage is allowed during the cell pressure application, and then without allowing the further drainage, the deviating stress is increased, keeping the cell pressure constant. Similarly, for the consolidated drain test, this is similar to the CU test except that the stress is increased and the drainage is permitted during that stage, and the rate of loading must be slowed down to ensure that no excess pore water pressure get developed during this condition. I'm talking about the significance. The first stage simulate the laboratory in situ condition that the soil is at different depths is subjected to different effective stresses. So it represents the actual three-dimensional case which the soil is facing in a real sense, and talking about the consolidation will occur if the poor water pressure which develop upon the application of the confining pressure is allowed to dissipate. Otherwise, the effective stress on the soil is a confining pressure or the total stress minus the pore water pressure which exists in the soil. During the shearing process, the soil sample experiences the axial strain and either the volume change or the development of the pore water pressure to occur, because we are talking about the total stress parameter and the magnitude, and you are already clear about the total and effective stress parameter when we talk about C and phi and C dash and phi dash. So the magnitude of shear stress acting on the different plane of the soil sample is different. When at some strain the sample fails, the limiting shear stress on the failure plane is called to be the shear strength. Now talking about the advantages of the triaxial test over the direct shear test. So the soil sample are subjected to the uniform stresses and strain, and the different combination of the confining and the axial stresses can be applied. A drained and undrained condition can be carried out, and pore water pressure measurement is one of the best advantage over there, which is not possible in the direct shear test or the box shear test. The complete stress strain behavior could be determined over here, and with the help of that only we are able to form the Mohr circle. And when we talk about the PQ curve which is coming ahead, so over there we will discuss about those. But now talking about the total stress approach, if the soil is clay, the Mohr circle form is similar in manner, and when a common tangent is drawn to the Mohr circle, it will become horizontal and parallel to the horizontal axis, resulting in showing that it is a completely cohesive soil. Only C is come and phi is 0, which is represented over there. And how it get plotted? First of all, the sigma 3 is applied. After that, the deviatic stress is applied, and the deviatic stress is sigma 1 minus sigma 3. And as the sigma 1 and sigma 3 is found and it is plotted, after that the some sigma 3 dash is applied, and after on the basis of that the sigma 1 dash is calculated, and then again that plotted. After that a common tangent is drawn in order to find the value of C and phi. Talking about a mover circle for the U test plotted in term of the total stress have a same diameter. The failure envelope is horizontal straight line, and hence the phi UU is going to be 0. It can be represented by equation as the tau F equal to CUU equal to sigma 1 minus sigma 3 by 2. And when you're talking about the CU and CD test over there, the phi CU and phi CD value will be found when we measure the angle with the horizontal plane, and the C and phi will be the intercept at which these are intersecting when the common tangent is drawn to the Mohr circle envelope. To form the Mohr circle envelope. For the test involving the drainage in the first stage, when the Mohr circle are plotted in terms of the total stress and the diameter increases with the confining pressure, resulting in the failure envelope. Each inclined line with the intercept on the vertical axis, which has been already called, and the intercept is the cohesion, and the angle measured with horizontal is the friction angle. It can be stated that the identical soil sample tested under the different axial condition UUCUCD test, the failure envelope is not unique, and this is why, because we are talking about the total stress approach. But when we move to the effective stress approach, the result confined by the three tests will show the exact outcome. So effective stress parameter, when we talk about, is the same triaxial test result UUCUCD test are plotted in terms of the effective stress, making into the consideration the major pore water pressure. It is observed that all the Mohr failure envelope are tangent to the same failure envelope, and indicating that the shear strength is a unique function of the effective stress on the failure plane. Now going ahead, when we see this failure envelope is the shear strength envelope, which may be written as tau f equal to C dash plus sigma dash and phi dash, where C dash is the cohesion intercept in the term of effective stress, and phi dash is the angle of shearing resistance in term of the effective stress. So the sigma n dash is the effective stress acting on the rupture plane. Phi dash is the angle of resistance in the effective stress, and the sigma n dash is the effective stress acting on the rupture plane at the failure, and tau n is the shear stress. The tau n is the shear stress on the same plane, and is therefore the shear strength. Now we interrelate the sigma 1 and sigma 3 as sigma 1 dash equal to sigma 3 dash into 1 plus sine phi dash by 1 minus sine phi dash plus 2c dash root under 1 plus sine phi dash by 1 minus sine phi dash. It is interrelated in the another term as well, in the term of tan, as sigma 1 equal to sigma 3, sigma 1 dash equal to sigma 3 dash tan for 45 plus 5 by 2 plus 2c tan 45 plus 5 by 2, because the when we solve trigonometrically both is the same thing. Now talking about the triaxial testing in the geotechnical engineering. So in this we have understood the shear strength definition, and the mathematical definition of the weak plane is also represented, that is the tau is greater than tau critical. Over there the failure takes place. The factors which influences the shearing, the major factor are the earthquake, which can lead to the relative motion between the soil layer, a fault causing a portion of the ground to slip down, leading to the shear failure, and emphasize the understanding of the state of stress during the shear ring is crucial for the stability assessment. The other factors like the slope instability and some of the other activity like the construction activity can also lead to the failure. Talking about the application and significance, the engineering significance of understanding the shear strength in the geotechnical projects. Shear strength analysis help in designing the foundations, retaining walls, slopes. The role of shear strength is most important in assessing the stability of the natural and man-made structure. Human activity like the construction and exploration can alter the state of stress in the soil, and incremental change in the stress can lead to the shearing, especially along the weaker plane. Talking about the Mohr-Coulomb failure criteria, when a soil sample has felt the shear stress on the failure plane, define the shear strength of the soil. Thus, it is necessary to identify the failure plane. It is the plane on which the maximum shear stress act, or it is the plane where the ratio of shear stress to the normal stress is maximum. For the this present discussion, it can be assumed that the failure plane exists in the possible to apply the principal stress and to measure them in the laboratory condition in a triaxial test. Talking about more in the Mohr-Coulomb failure criteria, the Mohr circle of a stress at failure of the sample can be drawn using a known value of a physical principal stress. And if the data from the several tests carried out on the different sample up to failure is available, a series of the Mohr circle can be plotted. And it is convenient to show only the upper half of the Mohr circle. A line tangent to the Mohr circle can be drawn and is called the Mohr circle failure envelope. So here the Coulomb failure envelope has been shown with this diagram, and here we can see that the common tangent to the different Mohr circle is forming the Mohr Coulomb failure envelope, and the intercept on the y-axis is the cohesion, and the angle made with the horizontal is the angle of internal friction. Now moving to the more concerning part, when we came to know that we came to understand that how sigma 1 and sigma 3 are plotted. So we I have discussed like this as well. And first of all, we have applied the sigma 3 dash, and accordingly we find the sigma 1 dash, and going ahead one by one steps, the sigma 3 2 dash has been plotted and sigma 1 dash has found it. And after that, a common tangent has been drawn, and then the intercept on the y-axis is showing cohesion, and the angle with the horizontal is showing the angle of internal friction. So talking about this, if the stress condition for any other soil sample is represented by the Mohr circle that lie below the failure envelope, every plane with the same experience shear stresses, which is smaller than the shear strength of the sample, so it doesn't get filled. But if the point of tangency of the envelope of the Mohr circle failure gives a clue to determine the inclination of failure plane. And one more additional point I want to add over here, like when any point below the Mohr circle failure envelope is there, that is safe, and over there the whatever the stress is coming is doesn't going to fail, but if any point going above that, it will lead to failure at that position. I think so that thing is very much clear to you, because this discussion has been done again and again at the several aspect of time. Now, in a triaxial test as a 3D depiction of the stress on a material, it offers a better replication of in situ stress condition and help in understanding the soil behavior under the more complex loading conditions, because it replicate the actual loading condition in process. Talking about the different aspects which has been used, like the in a triaxial test are like it is carried out in the cell of the cylinder soil specimen having the length to dia ratio 2, and the usual size is 76 into 38 into 100 or 100 into 50. The three principal stresses are applied in the soil sample, out of which two are applied by the water pressure. So that why sigma 1, sigma 2, sigma 3, two stresses are same. That's why the 2D representation calculation could be performed, and the third principal stress is applied by loading the ram through the top of the cell, and is different to the other two principal stress, and the typical triaxial cell is shown in this diagram over here. You can see that how the cell pressure is applied and how the pore water pressure back up. This is discussing very much detail, so I'm not going to discuss over here because this is a revision session over where I try to summarize all the parts. Now, talking about the procedure, we have studied the procedure that how the test setup go on earlier as well today in today class as well. So I will not try to take it. Now, talking about the triaxial test, the fundamental. So its setup, types of test, and the significance of parametric analysis is very much important while studying. The first stage and second stage is already discussed. This has been come again due to some problem. And the stage one is over there where the confining pressure is applied, like the sigma 3. So it is applied from two direction in the identical way, while in the third direction the another stress has been applied. Okay. While the deviating stress position here has been also represented over here. So this is another diagram, triaxial test setup which has been shown over here. Now, understanding the triaxial testing, the purpose is to evaluate the shear strength parameter of soil. The sample collection is one of the parameter in which the exact cylindrical sample of the field has been taken and then the setup is mounted as it has been shown in the previous picture. So mounted on the porous stone sandwich between the loading and the base plates. The CD test, U test, UU test, and UCS are the sum of the tests. Talking about inside the triaxial test, the CD, U, and U are the three type of triaxial tests which are usually performed. Talking about the pore water pressure meter, pressure measurement. So it is important to understand the influence of pore water pressure. The value used to apply the back pressure or the measure the pore water pressure is the part of the measurement setup and the impact consolidation untrained and unconsolidated untrained test with the influences of test types. Talking about the shear strength parameter like cohesion and internal friction are the shear strength parameter. The triaxial test offer a comprehensive insight into the soil behavior and okay, sorry. So, talking about the design implementation, derived parametrical crucial for the geotechnical designs. Now, talking about the significance, it is one of the most important tests which could be used to find the main parameter of the soil before starting any another test on that, and it provides a holistic view in the soil property in the various conditions, the fundamental for the accurate design and construction. Talking about significance, the first stage simulate the laboratory in situ condition that the soil at the different depth is subject to the different effective stresses. And the consolidation will occur if the pore water pressure which develop upon the application of confining pressure is allowed to dissipate. If doesn't this happen, the effective stress on the soil is the confining pressure or the total stress minus the pore water pressure which exists on the soil. Okay. So, talking about during the shearing process, soil sample experiences the axial strain and either the volume change or the development of the pore water pressure occurs. The magnitude of the shear stress acting on the different plane in soil sample is different. When at some strain the sample phase, this limit this limiting the shear stress on the failure plane is called the shear strength. Now, see, when we recap this section, the triaxial test stand as very important in the geotechnical engineering, offering the profound insight into the shear strength parameter of soil by performing the different type of triaxial test and incorporate the pore water pressure measurement. The engineer gain the comprehensive understanding of the behavior. The decision understanding is crucial for making the information informed decision in the geotechnical engineering. The construction project ISL test remain the timeless and essential tools that continue to shape the field of geotechnical engineering. Now talking about the some of the more point like the Scampton parameter A and B, the where B is delta U by delta sigma 3 and A dash A bar is equal to AB and A bar is equal to delta U by delta sigma 1 minus sigma 3. So ultimately we are able to find the Scampton parameters, and on the basis of that we are able to determine the value whether the soil is saturated or not saturated, and on the basis of that test can be proceeded. Now we will move to the earth pressure theory which we have read, and we will go very quickly in the earth pressure theory as well because we are running very late. It is 4:23 and we have to complete many slides before ending the today's session. So not to worry, I will cover the entire thing. We have the time with us, not very less and not very more, but I will try to cover the entire session. See. Now the and these things I have been already taken in class, so this is only the revision session over. I try to sum up the entire concept. So we have read the Rankine Earth pressure theory. Earth pressure theory at rest in active and passive state condition. So, to analyze the pressure relation between the retaining walls and soil masses, the most commonly used theory is the Rankine earth pressure theory. The three conditions are analyzed in the Rankine earth pressure theory, that is the wall at rest, active earth pressure, and the passive earth pressure. Rankine theory assumes the wall to be smooth and cohesionless, and this theory also extended to the cohesive soil, and this has been extended by the bells. So, we will look how. Now, the retaining wall and the backfill. Every time it is not possible to place the soil until it is, has a greater shear strength, then we construct the wall to keep it placed and will fill the soil back to it. It is called the backfill, and the wall is called the retaining wall. If the wall hadn't been there, the soil mass could have come out, which implies the soil mass is applying some pressure on the wall, that is called the earth pressure. So we should design the retaining wall against the earth pressure. So over here you can see that the soil which has been represented over here is actually the backfill, and the wall which has been constructed, that is preventing the soil to moving in the downward direction, is the backfill. Okay, so the retaining wall and backfill concept will be clear in everyone's mind. Now see, when we find that talking about the design of retaining wall, while designing a retaining wall, the following points should be kept in mind. Water does not have the shear strength, hence the stress in the vertical and the horizontal direction are the same. Whereas the soil has some shear strength and the horizontal shear stress is a function of vertical stress. Talking about the types of wall movement, the wall will attain the three conditions at any point of time according to wall position. Earth pressure changes the three general conditions which could be developed. First, the wall does not move or the wall is at rest, and the second one is the wall move away from the backfill, the active earth pressure condition. In third condition, wall move toward the backfill, that is the passive earth pressure condition. And you should understand that in the active earth pressure condition, the stress which has been applied from the top and bottom direction will be more as compared to the horizontal direction, and same the vice versa with the case with the when wall move toward the backfill. Now see, you see what do we mean by wall at rest? Wall at rest is that condition in which the there is a no movement of wall takes place, neither the soil is moving toward the soil nor it is moving away from the soil. So that is the condition of rest condition. So in this condition what takes place? The wall and the base of are rigid, which make the wall to stay at the single place and without any movement. As the wall does not move in any direction, the lateral strain ratio of change to the area to the original area is 0. Talking about the active earth pressure, wall move away from the backfill and the wall move in one direction, that is far from the backfill, and wall and its base is not rigid under the these cases. Here we represent the diagram, schematic diagram showing the active earth pressure condition. In this, the wall is moving away from the backfill. The retaining wall move away from the backfill because it is vertical. Now it has moved away. Talking about the second condition, as the wall moves away from the soil. First of all, this condition only because of the sum of the pressure of the soil gets relieved. And hence, the shear resistance get mobilized, and it is in the opposition of the wall movement. The shear resistance is the opposite direction, so the pressure in the horizontal direction get reduced. As the wall keeps moving away, we will reach at a condition where a full shear resistance would be mobilized. After that point, there will not be any further resistance if it moves away. So, because we understand that at certain point of time that condition come when there is no stress remaining in that direction to move the wall to for with the backfill to move the wall away from it. Similarly, the horizontal pressure would be minimum in this case exactly because it has been reduced. The stress has been relieved. So that will be minimum, that will be very easy understanding by one and all. Now, talking about the passive earth pressure. In passive earth pressure, wall moves toward the backfill, and due to mass of creating a wall and speed at which it moves, the mass of the soil backfill tends to move upward. There is no confusion over there. Oh, now you see the schematic diagram represented over here, which has been showing that the wall is moving toward the backfill. So in this case, the stress in the horizontal direction, pressure will be more as compared to vertical. So the shear resistance act in the same direction as the horizontal pressure. There will be a situation where the stress can't maximum, and that is the condition when the maximum stress has been achieved and the passive earth pressure get developed. Okay. Now see, talking about the Rankine Earth Space Theory, some more points I want to add on. That is the Rankine theory assumes there is a no wall friction, that is delta equal to zero. The ground and the failure surface are the straight planes, and that result force act on the parallel to the back slope. In the case of the retaining structure, the earth retaining wall may be filled up earth or the natural soil. These backfill material may exert a certain lateral pressure on the wall. If the wall is rigid and does not move with the pressure exerted on a wall, the soil behind the wall will be the state of elastic equilibrium. So now here we discuss these terms in very detail. So we find that the earth pressure constant is the ratio of earth pressure in the horizontal direction to the earth pressure in vertical direction. So sigma h by sigma b is the earth pressure constant. Whenever we are talking in rest, active or passive condition, the same will be case, and on the basis of that we have derived our interrelation. The Rankine earth pressure theory was only applicable to the uniform cohesionless soil. So originally it is proposed by Rankine, but later in 1915 it has been extended Rankine theory for the cohesive soil as well, and it has been used in where over there all plastic equilibrium remain the active and passive earth pressure. This means for every point in soil the shear failure is just about to happen. In reality, only a part of soil mass will be in the plastic equilibrium, but there the assumption is there. Assumption of the Rankine theory, some of the important assumptions Rankine theory have is like the soil is isotropic homogeneous, which means that the C, phi, and gamma have the same value everywhere, and they have the same value in the all direction at every point. That is, the strength of the vertical plane is same as that of the horizontal plane. Note that the theory is also applicable for the multi-layered soil having the different C, phi, and gamma in the different layers. So that is the assumption only because for the different layers soil the C, phi, gamma will vary at each location. Some more assumption like the wall is infinitely long, hence the problem may be analyzed in only two dimension 2D geotechnical engineering considered in a plane strain condition, and the ground surface is a plane although it does not necessarily need to be level, and there is no wall friction, that is delta is equal to 0, and the wall moves sufficiently to develop the active or the passive condition. The most critical shear surface is a plane. In reality, it is the slightly concave, but this is a reasonable assumption, especially for the active cases, and it simplifies the analysis. The resultant of the normal and the shear force that act on the back of the wall is the angle parallel to the ground surface. Talking about the Rankine earth pressure theory separately when at rest, the theory of the elasticity is used here. There is zero displacement, so zero strain, and the soil is homogeneous, isotropic, and semi-infinite. The elastic modulus and the Poisson ratio is the constant for the total soil masses, and the coefficient of earth pressure at rest condition or at rest earth pressure constant is defined as K naught, and it is the ratio of horizontal shear stress to the vertical shear stress as discussed above, and this can be represented as 1 minus sine phi, where phi is the angle of internal friction, and in another sense it has been also represented as mu by 1 minus mu. So both is the case with the earth pressure constant at rest. Now see, Talking about this condition only at rest of the earth pressure coefficient cannot is applicable for the determining the active pressure in clay for the saturated system because of the cohesive property of clay. There will be no lateral pressure exerted in the at the rest condition up to the some height at the time the excavation is made. However, with time, creep and swelling of the clay will occur and a lateral pressure will develop. The coefficient takes the characteristics of clay into the account and will always give a positive lateral pressure value. The lateral earth pressure acting on the wall of height h may be expressed as sigma h equal to k naught into gamma h and the total pressure is 1 by 2 k naught into gamma h square. So that is nothing but the area of that stress diagram with the special coefficient k. Now, the value of K naught depends on the relative density of sand and the process by which its deposit formed. If the process does not innovate the artificial tempering value, it ranges for 0.4 to for loose sand to 0.6 for dense sand. And its overall range has been also represented in a slide which has been shared with you when I am taking this session. So I haven't kept that slide over here, but you can go across. And that need not to be remembered. That will only give you a basic idea. Some more interrelation has been represented here. That is not the part of your syllabus. This is the extra term, so you can avoid this. And what do we mean by 1 by 2 k naught gamma h square? So this has been a stress diagram with the k naught value has been plotted, and on the basis of that, when we find the area, that is the p naught which has been acting at h by 3 from the base. And similarly, the stress at a specific depth is nothing but k naught into gamma z. Over here, the soil is not layered soil, only one property soil is there. If the stratified soil is there, we differentiate the k naught and gamma z, and specifically if the phi value is also different than the okay. Over here we are talking about the stress at rest, so the k naught will be the case, but if the when we move forward active and passive, so there you will see that the variation in k takes place and the diagram is not always linear, it will vary from different section to section. The resultant pressure at rest act at h by 3 which has been shown from the previous diagram from the bottom of the pressure diagram p naught, and p naught is nothing but 0.5 into k naught into gamma h square. Now see active earth pressure condition, and we have already discussed the passive, now we move to active. So in this condition, the wall moves away from the backfill and the phase of the plastic equilibrium in soil refers to the condition where the every point in the soil mass is on the verge of failure. Talking about the general formula for the lateral phase, the sigma h, the active condition, the sigma h is the k into gamma z minus 2c root k, where k equal to 1 minus sin phi by 1 plus sin phi. Or when we solve it trigonometrically, its value also becomes tan square 45 minus phi by 2. Now, when this entire relation has been written as k gamma z, where k is replaced by tan square 45 plus pi by 2, so this relation comes, and that is the thing with which we solve the problem. Okay, we have discussed these concepts as well, in which the pressure distribution diagram can be represented over here, where you see minus 2c gamma root k is at the top at z equal to 0, and when at z equal to zc over there the value is 0, and for the unsupported depth of excavation, that is the 4c by gamma root k is there, and the horizontal pressure at z equal to 0 is k gamma z minus 2c root k. For z equal to 0, sigma h equal to minus 2c root k is also plotted for the same cases. For cohesive soil, the C is 0, so the expression for the lateral pressure becomes K gamma Z. And this is the actual term which has been given by Rankine. And it has been modified by the Bells and his coordinates for the cohesive soil, because for the cohesionless soil, there is no cohesion, so not a problem at any point of. Talking about the coefficient K over here, that is 1 minus sin phi by 1 plus sin phi, or tan square 45 plus minus phi by 2, or cot square 45 plus phi by 2, same thing is there. So the sigma h equal to gamma j tan square 45 minus pi by 2. In this case, the negative side of pressure distribution diagram will not be there, because at z equal to 0, sigma h equal to 0, and the pressure distribution diagram start from the origin. Now, when we see the failure plane, how it make angle has been represented. So the failure plane in the soil make an angle 45 plus pi by 2. degree angle with the direction of the major principal planes that is represented over here, and these are called the potential slip planes. Now the some more points has been represented over here, so I am not going to discuss this. This has been given. You go across the main PDF for this. Now we will move to the passive expression. Because of the limitation of time, I have to move forward in little faster manner. Okay, see, in this condition, the retaining wall moves toward the soil mass backfill, and the formula and the expressions are quite similar to the active state. Some positive, negative sign changes in the active state formula will do our job. This way, it's very easy to remember this formula as the remembering is also important. So these are interrelated over there. Plus and minus sign is only replicated, and we are able to form. So over there you see 2c root kp is there. So that will be in addition. So first of all 2c root kp is plotted, and in addition the linear variation of stress has been plotted. So this type of stress distribution has been shown for the passive earth pressure. And for the quotient while when the C is 0, the Kp gamma Z is the only term, and Kp is 1 plus sin phi by 1 minus sin phi. And so the sigma H is gamma Z into 10 power 45 minus 5 by 2, which has been mentioned over here. Okay, I think so. Up to this, everything is clear in everyone's mind. I think so. There will be no problem. Okay, now we talk about the failure plane. As we have seen, the failure plane in excuse me for a minute. Okay, no problem. I will go ahead. See, so now you will find that the failure plane has independent over here. Okay, so this is the similar condition which we are discussing. Now we talk about the Coulomb wave theory in very brief, and then we will move forward. See, Coulomb theory provides a method of analysis that gives the resultant horizontal force on a retaining system for a slope of wall friction, and the slope of the backfill provided. This theory is based on the assumption that the soil shear resistance develop along the wall of the failure plane and the following coefficient for its resultant pressure acting at an angle. Since the wall friction required a curved surface for sliding to satisfy the equilibrium, the Coulomb formula will give only the approximate result as it assumes the planar failure surface. The accuracy of Coulomb will diminish with the increasing the depth for passive pressure. The Coulomb formula can also give the inaccurate result when there is a large back slope or the wall friction angle. These conditions should be investigated in the increased factor of safety considered. And the Coulomb 1776 developed a method for determination of the earth pressure in which he considered the equilibrium of the sliding wedge, which is formed when the movement of the retaining wall takes place. The sliding wedge is torn off from the rest of the backfill due to the movement of wall in the active earth pressure case. The sliding wedge moves downward and outward on a slip surface relative to the intact backfill, and in the case the passive earth pressure and the sliding wedge moves upward and inward. The pressure on the wall is in fact the force of relation which it exerts to keep the sliding wedge in equilibrium, and the lateral pressure on the wall is equal to the opposite reactive force. The Some of the assumptions which are made, like the backfill is dry, cohesionless, homogeneous, isotropic, and ideally plastic material, elastically undeformable but breakable. The slip surface is a plane surface that passes through the heel of the wall, and the wall surface is rough. The resultant earth pressure on the wall is inclined at an angle normal to the wall, where the angle of the friction between the wall and the back. The sliding wedge itself acts as a rigid body, and the value of the earth pressure is obtained by considering the limiting equilibrium of the sliding wedge as a whole. The position and the direction of resultant earth pressure are known, and resultant earth pressure act on the back of the wall at one-third height of the wall from the base, and is inclined at an angle normal to the back, and the angle is called the angle of wall fix. The back of the wall is rough, relative movement of the wall and the soil on the back takes place, which develops the frictional force that influences the direction of resultant pressure. Okay. Now, in Coulomb theory, a plane failure is assumed and a lateral force is required to maintain the equilibrium of the wedge is found using the principle of statics. The procedure is repeated for the several trial surfaces. The trial surfaces which gives the large force for the active cases and the smallest force for the passive cases in actual failure surface. This method radially accommodates the friction between the wall and the backfill and the irregular backfill sloping walls and the surcharge loads. Okay. Now talking about the some more point, that is the sliding wedge, the weight W is there, which is found by taking its area and multiplying by gamma, and the reaction R and Px is also there. So that is one of the case. Okay, I think so. These things has been discussed very clearly. So I will not go over here in detail. Now I will move ahead, and the wall faces the active earth pressure and passive earth pressure will act because the backfill is there. When it move toward the backfill, passive earth pressure is there. Move away from the backfill, active earth pressure is there. If the wall remain there, the earth pressure at rest condition get established. Okay. When we talk about the distribution of active earth pressure, the sigma A equal to K into sigma Z minus 2C root K, where K equal to 1 minus sin phi by 1 plus sin phi equal to tan square 45 minus phi by 2. Now, talking about the distribution of passive earth pressure, sigma P equal to Kp into sigma Z plus 2C root Kp, where Kp equal to 1 plus sin phi by 1 minus sin phi equal to tan square 45 plus phi by 2. Talking about the inclined ground surface, which has been also represented, and K and Kp is also represented when the ground surface is inclined and this interrelation get established. So you will go ahead with those interrelation stating the different relation according to Coulomb theory. The active earth pressure interrelation for active and passive earth pressure coefficient has been shown over here. So I will not go in that much detail for the discussion of those facts. Earth pressure do effective stress in the soil using the effective unit weight, and the earth pressure due to the hydrostatic stresses of the water. Now the graphical method is also there which is presented. So I will move now to the seat piles in the geotechnical engineering. As we know, the seat piles are the vertical barriers which made to interlocking the steel or concrete seats that are driven into the ground to provide the support for the excavation or the prevent the soil erosion. They are commonly used in the construction and civil engineering projects. The seat pile walls are typically thinner than the masonry or the reinforced concrete retaining walls, such as cantilever retaining walls. They can be constructed using the materials such as steel, concrete, or timber. The steel seat piles are most commonly used type of seat pile wall due to their strength, durability, and versatility. And the seed pile walls are used in the wide variety of applications, including The retaining walls, seed pile wall can be used to retain the soil and prevent the landslides, especially in the area with the steep slopes or the unstable soil conditions. Talking about the coffer dam, the seed pile walls are often used to create the coffer dams, which are temporary to ensure the allow the construction to take place below the water level. The sea walls and the bulkheads are the another part where the seed piles walls has been implemented. Seed piles walls can be used to support the foundation bridges, and the seed pile walls can be used to support the excavation to provide the support act as a support. Over here you can see one of the diagram which has been showing the seat pile walls are constructed by driving the prefabricated section into the ground, and the sections are interlocked to form the continuous wall. The depth or to which in the seat piles walls are driven depend on the soil condition and the required load bearing capacity of the wall. Talking about the seat pile walls offer a number of advantages like it has the strength and durability, it has flexibility, and it gives the boost up in the speed of construction. Apart from that, seat pile walls can be made watertight, making them ideal for the use in the application where the water exclusion is important because first of all seat pile wall support the give us support and the water is removed, and after that the construction process could takes place at those specific. Now we talk about the anchor bulkheads. Anchor bulkheads are the retaining wall that are used to prevent the soil erosion and to provide the area suitable for docking. The anchor bulkhead are typically constructed by driving the steel seat piles into the ground and then the anchoring them to the tie system. The tieback system can be made of steel cables, rods, or stirrups. The anchor bulkheads are used in the variety of applications like the waterfront structure, riverbank stabilization, highway railway construction, and land reclamation. Apart from that, the components of the anchor bulkheads are the seat piles only, tiebacks, water scoping, gravity bulkheads, and the cantilever bulkhead. Now, talking about the different type of anchor bulkhead are the gravity bulkhead and the cantilever bulkhead. The gravity bulkhead rely on their own weight, while the cantilever bulkhead rely on the tieback system to resist the lateral acceleration. Gravity bulkheads are typically used in the shallow water application, while the cantilever bulkheads are normally used in the deep water application. Talking about the design of anchor bulkhead depends on the type of soil over it applications takes place, and the depth of water is also similarly of importance. Another two factors are the height of the bulkhead and the surcharge load which are coming on the bulkhead. Talking about the construction of anchor bulkhead, the construction of anchor bulkhead typically involves the some of the steps like the seat piles walls are divided into the ground, the tieback system are installed, the waller is connected to the top of the seat piles, and the coping is placed on the top of the seat piles. And the designing of anchor bulkhead is understood by us. Now the advantages which it offers needs to be understood. The advantage that it offers is that they can be installed in the variety of soil conditions, they can be installed in the confined space, they have a high load carrying capacity, and they are relatively quick and easy to install. Talking about the disadvantages, they can be expensive to install, they require the regular maintenance and inspection, and they are susceptible to corrosion as well. Talking about the some of the more disadvantages, okay, no, these are the same disadvantages which has been mentioned in the previous slide. Talking about the application, waterfront structure, riverbank stabilization, highway railway, and land reclamation. This is also discussed. Now talking about some of the history about the anchor bulkhead. Anchor bulkhead has been used over 100 years. The first anchor bulkhead were built in the 19th century to protect the coastline of Europe and North America from erosion. The anchor bulkhead were also extensively used in the construction of Panama Canal in the early 20th century. This is the one of the case study which could be taken care of understood where the anchor bulkhead has been used. Talking about the design procedure which is followed in the anchor bulkhead, first of all, the site investigation takes place, and then the structural analysis is performed to determine the load that will applied on the bulkhead. Afterward, the design of sheet pile wall to resist the lateral pressure is found, and then the tieback system is designed. The site is prepared by clearing the area of debris and leveling the ground. The construction process of the anchor bulkhead is discussed already. That is a similar slide has been came over here again. Now we move to the slope stability, which we have discussed at the end of the section. So first of all, I will discuss the slope stability of the detail extent, and then we have some small problems, objective types, which we discuss, and at with that we will conclude the today's session. Okay. So first of all, see, we are talking about the introduction. That what do we mean by slope failures? The slope is a crucial part of the structure. Over here, you can see that the vegetation is there all around, and in between the soil get collapse, and in the downfall, you see there are too much construction is there, and that is submerged due to that fall. So this type of failure is quite dangerous and very risky in order to protect the people life. If some construction are there which get damaged, some people may be there, they could be submerged due to these landslides and may lose their life and may become. So this is one of the most hazardous situation which one once arise. So the stability of slopes is needed very much. Over at different places you see that the stability has been shown. As you see, the too much vegetation is there in the top right images, and in mid between there is a flat section has been represented. So the failure takes place from that sections at several occasions. So those things need to be understood and found in that whether it will be achieved or not. Okay. Now see, the India overall topography is also represented over here in the diagram, and talking about the slope and its necessity. So an exposed ground surface that stands at an angle B with the horizontal is called slope, and the construction of highway and railway over there it has been necessary. Apart from that, the embankment, earth dams, lifts and canals are also some of those influent parameter. Talking about the type of slopes, there are two types of slopes maybe there. That is the infinite slopes and the finite slopes. When we talk about the infinite slopes, they have the dimensions that extends over the great distance, and the soil mass is inclined to the horizontal. You see over here that how the resistance is offered and what is the sliding surface. So the how the W get act. Similarly, for the finite slope, a finite slope is one with the base and the top surface are at height being limited, and the inclined face of the earth dams, embankment and excavation and like are all finite slopes. So over here the symmetric diagram has been represented for both. Talking about the types of slope, the natural slope could be there and the man-made slope could be there. The natural slope is formed by the geological feature of earth, while the man-made is constructed activity like cutting and filling lead to the formation of those slopes. In general, the natural slopes are most of the slopes are the natural slopes, where limited are the man-made slopes. Now we need to understand that why we want to understand slopes, because the failure of the natural slopes, landslides, and the man-made slopes has resulted in the much of loss of life and destruction. Civil engineers are expected to check the safety of natural and the slopes of excavation. Slope stability analysis consists of determining the comparing the shear stress developed along the potential rupture surface with the shear strength of soil. The attention has to be paid to the geology, surface drainage, groundwater, and the shear strength of the soil in accessing the slope stability. Slope failure triggering mechanism are like the intense rainfall, water level changes, seepage water flow, volcanic eruption, earthquake shaking, and the human activity like excavation can lead to the failure of slope that will act as a trigger for the slope failure. Causes of slope failure. Erosion is one of the causes. The wind and the flowing water causes erosion of the top surface of the slope and makes the slope steep and thereby increasing the tangential component of the driving force. Steady seepage force is in the sloping direction added to gravity forces and make the slope susceptible to instability. The poor water pressure decreases the strength. This condition is critical for the downstream slopes. Talking about the sudden drawdown, in this case there is a reversal in the direction flow and the result in instability of side slope. Due to the sudden drawdown, the shear stress are more due to the saturated unit weight, while the shearing resistance decreases due to the poor water pressure that does not dissipate quickly. Rainfall, the long period of rainfall saturates, soften and erode the soil. Water enters into the existing cracks and may weaken the underlying soil layers, leading to the failure, for example, mudslides. Talking about the cause of slope failure, the earthquake, it includes the dynamic shear force in addition. There in a sudden buildup of pore water pressure that reduces the available shear strength. External loading, like the additional load has been placed on the top of the slope, increases the gravitational forces that may cause the slope to fail. Talking about the construction activity at the toe of the slope, like the excavation at the bottom of the slope surface, will make the slope steep and thereby increasing the gravitational forces, which may result in the slope failure. Here you see the crest has been shown, crest of the slope and toe of the slope, the center of rotation is also represented, the slope has been provided. The slip failure surface and the sliding mass has been represented in this diagram. The slip or the failure zone, it is the thin zone of the soil that reaches the critical state or the residual state and result in the movement of the upper soil mass. The slip plane or the failure plane or the slip surface or the failure surface, it is the surface of sliding. Talking about the sliding mass, it is the mass of the soil within the slip plane and the ground surface. Talking about the slope angle, it is the angle of inclination of a slope to the horizontal. The slope angle is sometimes referred to as the ratio. For example, the two horizontal, one vertical is one of the slope angle. The type of failure which takes place is the phase failure, that is slope failure, two failure, and base failure. All three are represented over here. Like the phase failure has been represented, this type of failure occurs when the slope angle is large and when the soil is at the top position is strong. Talking about the two failure, in this case, the failure surface passes through the two, and this occurs when the slope is steep and homogeneous. Talking about the base failure, in this case the failure surface passes below the two and this is generally occurs when the soil below the two is relatively weak and soft. Talking about the analysis of slope, the factor of safety of slope is defined as the ratio of average shear strength of a soil to the average shear strength developed along the potential failure surface. So Fs is the tau by tau d, and the shear strength of a soil is given by tau f equal to c plus sigma tan phi, where c is the cohesion, phi is the angle of internal friction, sigma is the normal stress on the potential failure surface. Similarly, the mobilized shear strength is given by tau d is equal to cd plus sigma tan phi d, and similarly the factor of safety is represented similarly. When we talk of factor of safety with respect to cohesion, Fc equal to C by Cd and Fy is equal to tan phi by tan phi d. When Fc is equal to Fy, the C by Cd become equal to tan phi by tan phi d. So Fs equal to Fc equal to Fy. When Fs equal to 1, then the slope is said to be state of failure. Talking about the finite slope. A finite slope is one with a base and top surface, the height being limited. The inclined face of the earth of the dam, embankment, excavation, and the like of all finite slopes. The investigation of stability of the finite slopes involve the following steps: assuming a possible slip surface, studying equilibrium of the forces acting on the surface, and the repeating the process until the OSH slip surface that is one with in the minimum margin of safety is found. The analysis method, finite slope Swedish circle, arc method, method of slices, standard method, and the Bishop simplified method and the Taylor stability method are some of the factors which need to be studied. So the Swedish circle method or the slices of the cohesive friction C5 method is adopted for the general type of soil which have the combined grains of C and 5 soils. For the C5 soil, the undrained strength envelope shown both C and 5 value. The total stress analysis can be adopted. The slip circle has been shown over here. Similarly, the Bishop simplified method and the Taylor stability number is there. So these points has been discussed during the class. So you can go over there and see these things. And the different cases analysis is also there, like the cohesive soil, cohesionless soil, cohesive soil, cohesion and friction soil. So those discussion has been earlier taken place. Now, now we take some of the small problems before ending the session on the slope stability. Okay, so the question is which of the following is not a factor that affect the slope stability? So the options are slope geometry, soil and rock property. Exactly, these two are the factors: groundwater, vegetation, and temperature. So from the options, it is clear that option E, temperature, is the answer because on which it doesn't depend. Okay. Now see the question number two. We say which of the following is the most common type of slope failure? Landslide, rock fall, debris fall, mud flow, or all of the above are they equally common? So I think so. You are clear with your answer, and the answer is A. That is landslides. Landslide is the most common type of slope failure which has been observed. Now move to the next problem, that is the limit equilibrium method are the most common type of slope stability analysis method because they are easy to use, accurate, they are both A and B or neither of A and B. So I think so your answer will be clear and that is going to be option number C. That is both A and B. Now we move to the next problem and this problem state that which of the following is not a slope stabilization method. So drainage, retaining wall, buttress, vegetation, so all of the above are the slope stabilization method. So it is very much clear in your mind. During the last class of our discussion, we came to know that all of these are the slope stabilization method because with the providing the proper drainage, stabilization could be achieved. Retaining wall is one of the factors through which the stabilization can be achieved. Buttress and the growing vegetation act as a reinforcement for the stabilization. Next question is which of the following is the most effective way to improve the stability of slope? So the options are reduce the slope angle, increase the shear strength of soil, reduce the groundwater level, or all of the above. So the option number D is the correct answer, that is all of above. Okay. Now the next problem is slope has the height of 10 meter and the angle 45 degree. Okay, this will take time. I will provide you. You will take these questions over there because the time has been ended. So I have to end the session. I will take the small problem. Or those problems are there, you will solve by yourself. And if any problem is there, you can write in the comment section when I upload the video. The question number 9 says the vegetation can help to stabilize the slope by providing the root reinforcement, reducing erosion, both A and B or neither A and B. So the option number C is going to be our correct answer. Okay. And after that, each of the following is not a good practice for improving the slope stability. So building on steep slope, deforesting slopes, excavating slopes, or all the above are the bad practices for improving slope stability. So I think so. You will tell that all the above are the bad practices for improving slope stability. Exactly. Now move to the next problem, that is what is the difference between a landslide and a rock fall? So the theoretical question has been answer has been written. A landslide is a mass movement of soil, rock and debris that slide down a slope. A rock fall is a type of landslide that involves the fall of individual rock or boulder from the slope. Okay, individual rock or boulder get fall down. That is the rock fall. So what is the debris flow? So, a debris flow is a type of landslide that is primarily composed of soil, rock, and water. Debris flows are often characterized by their high speed and destructive power. Now, question: what is a mud flow? So, a mud flow is a type of debris flow that is primarily composed of muds. Mud flow are often triggered by the heavy rainfall or the snowmelt. Next question is what is the purpose of slope stability analysis? So answer is the slope stability analysis is used to evaluate the stability of slopes and identify any potential risk of failure. Now the next question move when we are moving to the next question. Question state that what are the two main types of slope stability analysis method? So the answer is the two main types of slope stability analysis method are the limit equilibrium method and the finite element method. We have discussed about this in the last class. Now question what is the difference between the limit equilibrium method and the finite element method? So the limit equilibrium method involve the calculating the forces driving the instability and the forces resisting instability. The finite element method involve discretization of slope into the mesh of element and then calculating the stress and the strain of each element. So with this, I will end the session, and this is the concluding session for the entire coursework. So I will suggest you go ahead with the all the understanding which you gather from this course, and I'll wish you all the best for the exams which is going to be held for this course, through which you get your certification. And hope we will meet again in some another lecture series with you. Till then, all the best, everyone of you, and thank you for joining. And I think this coursework will be helpful for you. So, with this, I am concluding the session. Thank you, everyone.